there kids, welcome to another math video. This is for grade 5 Eureka Math, module 6, lesson 11, homework. The objective is at the bottom of the page. As usual, analyze number patterns created from mixed operations. So we're really working with the rules to make a line, and then adding or subtracting or changing to have a little something so that we move off the line, either above it or below it, or changing the angle of the line. So you as fifth graders are looking for the patterns in the operations to see what's happening and what kind of line do I create when I'm changing my rules. So let's get started. Let's get started reviewing it. Hopefully you already did it, but if you didn't, I'm going to talk you through it. A lot of kids are starting to get confused about what do I do and how do I apply this. And I always say make the formula first and write it on your paper so that you can plug in the value for x. So that's my help to you for this one. So complete the tables. If the rule is to double x, what does double mean? Well, that means 2 times the number. So you're going to take your x and you're going to multiply by 2 in order to get y. Now you don't put 2 here. You're putting the answer. You're putting y here. Okay, so whatever x is as its double, that's what y is. So you take the 1 that is x, and this is where we're going with algebra. You have to be able to substitute in numbers for letters. So you say if x is 1, then 1 times 2 is 2, and that's your answer. And then this is your ordered pair. And then we're going to go ahead and fill this in before we make our points. So if x is 2, then 2 times 2 is 4, and y is 4. So 2, 4. And if x is 3, 3 times 2 is 6. And so then you should have your 3 points that you can make for line L. So look at your number lines and see what are we counting by. That's also one of the first things you should do so that you can kind of get your graph set up. And then you can plot your points correctly. If x is 1 and y is 2, then I'm going to have this point here. 2, 4. And 3, 6. It's what I would call a steep line. You should have a straight edge nearby and make your line. Going through the origin here. Make arrows on the end so that you show it's a line. And this is line L. Put a little cursive L somewhere up off the top of the graph. And so let me make sure the volume's up. I haven't even looked at my iPad in a while. Okay, for the next one, we're going to also follow the rule for line L, but then we're going to have this mixed operation. We're going to subtract 1. So we're going to double x, so the formula will be x times 2. Still have to start with that. But after doubling x, you will then subtract 1. So your formula now has 2 steps. First multiply, then subtract. So you take your x value and you substitute it in. You plug it in. So instead of the x, you're going to put 1 here. 1 times 2. What's 1 times 2? 2. 2 minus 1 is 1. That's the answer. So your first ordered pair for this line is going to be 1, 1. Next one is 2. Plug in the 2 here. 2 times 2 is 4. 4 minus 1 is 3. And then this one is x. If x is 3, then 3 times 2 is 6, and 6 minus 1 is 5. So did you see how I read that through? And then you just put your answer, and now we're going to plot the points. So in my class, I am talking to my students about, let's say, if this is our baseline, okay, this is with our double x, and if I have side A and I have side B, where do you predict that the line will be? And they're starting to get the hang of it, that if you have whatever your rule is, and you add to it, you're going to be going this way. So predict now, if you're going to subtract, where will my line be? Well, it should be below. or to the right of, or down below this other line that we just made. So I'm going to have my 1, 1, and sure enough, it is to the right. And 2, 3, also to the right. And 3, 5, also to the right. Draw each line on the coordinate plane above. And we have line M. And compare and contrast the lines. So what do you notice about these lines? Well, first of all, they're parallel. And second of all, the second line with the subtraction is, when I divide them into two, I'm like saying, you know, you can say, kids, it's in section A or section B, but you have to identify that on your paper. So if you didn't write A or B, then you want to just say the subtraction would be on the lower part of the graph or below line L or to the right of line L. So line M, line M with subtraction is to the right of L. Okay, so if the original line where the rule is to double X is this way, then if you subtract, you're going to be down here somewhere, depending on what you subtract. If you only subtract 1, well, it's going to be 1 crossing point below. 1 crossing point below, since we're counting by ones. Okay, based on the patterns you see, predict what the line for the rule double X, and then add 1. Now, I've been talking about this the whole time. If you subtract and you're going to be below, then if you add, my prediction would be somewhere in section A. Okay, draw your prediction on the plane above. Well, if I have my double X, there's that, and then I add 1. If you want to make a little T-chart here and have your X, Y coordinates, we have only whole numbers, so you can put in any value you want for X and then follow the formula. So let's do, say, 2, 4, and 6. Then plug in the value. If X is 2, 2 times 2 is 4. 4 plus 1 is 5. 4, if X is 4, 4 times 2 is 8 plus 1 is 9. And what is the biggest number I could have on my graph? It's 10. So I might want to use something smaller than 6, because 6 times 2 is 12 plus 1 is 13, and it'll be off my graph. So thinking about the top value there, pull it back a little. 6 would be too big. I could do a 1 or a 3. Let's try 3. And then 3 times 2 is 6 plus 1 is 7. Now, I could have stopped here. I only need 2 points to make a line and just to prove where the line's going to be. So a 2, 5 is up here, and 4, 9 is up here. So I have these 2 points, and then I could fill in the 3, 7 right here, which you don't really have to, as long as you have your 2 points on the line. And they don't give us a letter for that one, so you just put the arrows on the end. And your prediction is that it would be above. It would be above or left of L. Okay, and then that worked out perfectly just like we thought it would. Now for the next one, circle the points, points that the line for the rule multiply X by 1/2 and then add 1 would contain. So multiply X by 1/2. Now you can do it the other way. You can say half of X also would work, and then add 1. I like to say it both ways, because if I was to say X times 1/2, students might not get that right off the bat. But if I said half of a number, then they usually buy into that really quick. Like, what's half of 8? Oh, it's 4. So it's the same thing. You're just flipping the order. So what you need to do here, it says explain how you know. The way you're going to know what the points are is by solving it. So it's by using the X. Use the X to get the Y. It may or may not match what they have here because they're telling you circle only the ones that actually give you the y. So let's say I start with 0, okay? If I plug in 0 for this, 0 times anything is 0. So then I would have 0 plus 1, which is 1. Did you get 1 here? No. That's why you know that one doesn't work. We need to follow the rule. Follow the rule and plug in your values. For this one, if I have 2, 2 is x, then if I was to set it up like this, remember that 2 is a whole number in a fraction would be 2 over 1. If I'm multiplying with these, I can do cross-canceling. And so I'm going to get 1 as my answer. Now remember, it's 2 times a half. What's half of 2? 1. And so 1 plus 1 is 2. So my final answer for y should be 2. Did you get 2 here? No. So this one does not work either. Now look over here. They give you the same x. And what did we get? We got 2. This one is going to work, so you circle that one. This one, you would apply the rule. So take 3 here. 3 times a half, or 3 half of 3 is 1.5. Now I can multiply this out and do 3 halves and then turn it into a mixed number here. But to the 1.5, you still have to add that second part. So you should end up with 2.5 for y. Did we get 2.5? No. So that one does not work. Okay? Use the x to get the y for all of those. I always used to just say, well, solve it. Solve the formula. Work it out. All right, give 2 other points that fall on this line. How do you do it? Use the formula. Use the formula. Put any x you want, use the formula. Okay, and it doesn't even have to be on the graph. So you could say, let's say x is 10. Okay, if x is 10, what's half of 10? That would be 5. 5 plus 1 is 6. So your point on the line would follow the rule and you'd have 10, 6. Okay, you can have something that's higher. Let's say x is 20. What's half of 20? It's 10. 10 plus 1 is 11. So that's what your numbers would look like on the line following the formula. You can have any other points you want. You don't have to use 10 and 20. You can use anything you want. Turn the page. Okay, complete the tables for the given rules. Line L is to have x and then add 1. So if I'm going to take half of x, then it's going to be a fraction or divide by 2. So it's kind of your option there. You can do half of x and then add 1, or you can do x divided by 2, okay, because really if I was multiplying x times 1, trust me, in higher algebra, that's what you would do, and you would just have x divided by 2. You have to do that first, then you add 1, x divided by 2 first, and then add 1. So this is step 1, this is step 2. The adding 1 is always step 2. So plug into any of these formulas, whichever one is most comfortable, the 0. And what does it do? Messes you up right off the bat because you're like, I can't divide with 0. You're right. So if I have 0 divided by anything, it's like not even rational, and so you're going to have 0. But I do get to add 1 to 0, so I will have 1 as my other coordinate value. So now that we have our whole number that we can use, what if I have 1 and I'm taking half of 1? So what is that? Well, it's a half, and then a half plus 1 is 1.5. So I'm going to look at my number line here, and I want to see, okay, because they just threw us off with our half values. Are we counting by ones anymore? And you say, oops, nope, we're counting by halves. So notice that your number line will now have half values, 1.5, 2, 2.5. And if you want to number a few of them just so you can get used to it, because we're so used to counting by ones, that is a smart thing. Okay, so second ordered pair, 1, 1.5, take your 2 and plug it in. So half of 2, what's half of 2? Well, it's 1. 1 plus 1 is 2. And if my value is 3, half of 3, that's 1.5. 1.5 plus 1, 2.5. Now let's plot these points and call it line L. 0 for x, don't go that way, but do go to 1. 1, 1.5. 2, 2. 3, 2.5. When you put your points down, you should look and see they are all in a line. If they're not in a line, and I make mistakes all the time, if they're not in a line, go figure out which point is wrong and why. Something is wrong, go find it, fix it. It's okay, we all make mistakes. I am constantly making mistakes. Okay, so the next one, and we have to label this line L. So this is our midpoint or our baseline. Okay, so we have half and then add 1. Now we're going to half x and then add 1.25. What do you notice here? Notice that our adding amount is 1.25, but we're only adding by halves. So you may not have points exactly on an intersection if you're not careful with the points that you choose if you have to make a new line for this one. So half x, oh, there go the lights. It's so fun. It's just like normal. It's just like a regular day. Okay, half x and then add 1.25. Same formula, half the x first, and then add 1 1/4. So just the adding, notice if your numbers are still 0, 1, 2, 3, it's going to have the same initial answer. You're just going to add a little bit more this time. So if I started out with 0, and I'm going to have 0 times the number that I have 0, plus 1.25, I will have 1 1/4. And so if I was going to plot that, remember, you may not have the point exactly on an intersection. So when we finish this up, I'll plot it there and I'll show you. So 1 for x, what's half of 1? Well, it's half, but then I have to add 1 1/4 to a half. So 1 3/4 would be your final y value. And then for 2, half of 2 is 1, and 1 plus 1 1/4, 2 1/4. And then for 3, half of 3 is 1.5, and 1.5 plus the 1 1/4, then you would have 2 3/4. There we go. All right, so where do these points go when we have all these fractional values that aren't even corresponding with the numbers on the line? That's okay. Remember, these axes here, the x and y axis, they are each a number line. Every single number in the world is on this number line. Okay, every fractional number in between the whole numbers still on the number line. You just have to figure out where it is. So for my point 0, 1 1/4, don't go this way, but we just go up 1 1/4. It's going to be halfway between 1 and 1.5. So it's going to be right here. That's where 1 1/4 is. Okay? How about 1 for x and 1 3/4? 1.5, here's 2, so 1 3/4 is again right smack in between the 1.5 and the 2. How about 2 and then 2 1/4? Here's 2. This is 2.5, so 2 1/4 is right smack in the middle. And then 3 and 2 3/4. Here's 2.5, but we know it's going to be just above it. How do we know that? Because it's following a pattern. All your points should be in a line that we're going to make now and show that it is parallel to the L line. Okay, parallel to. Draw each line, compare and contrast. They're parallel. This is line M. M is higher on the graph. Probably don't need to write that. Than L. And again, why is it higher? Because we're adding to it. We're adding even more. Here we added 1. Here we're adding 1 and a fourth. We're adding more. So each time you add to the rule, then you keep moving up higher. Based on the patterns you see, predict what the line for the rule have x, same start, and then subtract 1 would look like. So what do you think it's going to be? Well, if we start out with the same rule for L, but then we subtract, I predict, if this is section A and this is section B, I predict it will fall in section B. I predict that. Now, make your XY chart, throw down a couple of X values, follow the formula, and draw the line. So just to keep it simple, you can keep your 0, 1, 2, 3. I don't like the 0, so I just always leave that out. You really only need 2 values. So if I was going to take half of 1, I would have a half. Oops, but then if we're going to subtract, we want to have, I don't want to have that one. So I'm going to start with 2. Okay, half of 2 is 1. Okay, so I'm following this. I'm pointing this out here, but I'm using the 2 from here, and I'm using the formula over here. Half of 2 is 1. And then from the 1, because I'm going to do half of x and then subtract 1. 1 minus 1 would be 0. So my first coordinate pair is going to be 2, 0. 2 for x, but 0 for y. How about 3? Half of 3 is 1.5, and 1.5 minus 1 is a half. So 3 for x and then a half. So my line would then be parallel to the other 2 lines, but below in section B, just like where I thought it would be. Okay, so that's how you can guess about adding, how we go up, and then subtracting, we're going to go down further on the graph. If we're only adding and subtracting with the lines and using that previous rule, then they'll be parallel. It's when you start changing the rule and multiplying and dividing that you start to get the really slanted lines. Okay, almost done. For number 4, circle the points, pointer points that the line for the rule multiply x by 3/4 and then subtract a half would contain. So it's x times 3/4 or 3/4 of x. And when you get that by plugging in your x values, then we're going to subtract a half from it. So you start substituting in each x. Don't worry about the y. You're just trying to see, will I get that? So 1 times 3/4 is 3/4, and 3/4 minus a half makes 1/4. So look, we have a winner right away. And if you want to write this all out, you certainly may. I'm just kind of doing it in my head because I can. But substitute in your x value and see if you get the y. So 2 times 3/4, you can write it out. So I want to write it out here. And then solve, and you can cross cancel. So you end up with 3/2 or 1 1/2 minus the half. That gives us 1, and that is not what I got. So that's not going to work for that one. Substitute in the 3 for the x. Multiply it out. This one is 9/4 or 2 1/4. And I still have to take away the half, which would give me down below 1 3/4. And look, it works out. We actually get that. Now, notice again, if I already used the 3 here, I know what I will get. I should get 1 3/4. I should not get a 1, so that's not going to be a winner. Explain how you know. Apply the formula to any given x. And then for 2 other points that fall on the line, you're going to use the formula and make up your own numbers. Okay? So, oh, I can hear the janitor's right outside. I wonder if he's going to come in. I better hurry up. Use the formula. So let's take just some nice, easy whole numbers, even though we're working with fractions. Take, say, something bigger that we didn't have, like 10. And we're going to multiply that by 3/4 if x was 10. Ooh, that gives us a really big number. 30 divided by 4. And we're going to have 7.5. And then we're going to subtract 1/2. And we should get 7. Okay, and so you can, let's do something not quite as big, maybe like 6, because we don't have any of those over here. So use, say, a 6. And then we're going to do 3/4 of 6. Notice I switched the order because I can. I can even simplify this a little bit. 2 goes into 4 2 times, and 2 goes into 6 3 times. And that gives us 9/2, which is 4.5. And from that, I need to subtract the 1/2, and I would get 4. And I know it's all super smashed down in here, but that's what happens. So, anyway, you can come up with your own points. You do not have to use 10, and you don't have to use 6. You can come up with your own x values because you're just trying to prove that you can use the formula. So that's what that's all about. I hope this video was helpful, and we'll see you guys on the next video. Goodbye for now.